So here's our presentation about plastics and polymers.
Plastics are made up of polymers. Polymers are made up of a series of monomers, much like a chain of paper clips. The paper clip represents a monomer and the chain of paper clips is a polymer. Polymers can be made of both natural and synthetic materials. Cellulose, wool, and amber are some examples of natural polymers. Examples of synthetic polymers include styrofoam cups, plastic bags, and bottles. Alexander Parkes discovered the first plastic in 1855 with Parksine, which would pave the way for other plastic goods. Plastics are the most versatile polymers due to their durability, ability to be shaped or colored. They can be made cheaply and are made into millions of different products. With benefits came disadvantages as well. Because of their durability, any plastic in an ecosystem could potentially be harmful to the plants and animals. Plastic products have been a major problem in ocean ecosystems as animals have become trapped in it.
Manufacturers and processors introduce various fillers, reinforcements, and additives into the base polymers, expanding product possibilities. Polymers can be processed in various ways to produce thin fibers or very intricate parts. Polymers are materials with a seemingly limitless range of characteristics and colors. Polymers also have many inherent properties that can be further enhanced by a wide range of additives to broaden their uses and applications. For example, plastics can be melted into bottles or car bodies or be mixed with solvents to become adhesive or paint. Crystalline structures such as those in salts and gemstones usually come to mind, but not in plastics. Just as quenching can produce amorphous arrangements, processing can control the degree of crystallinity. The higher the degree of crystallinity, the less light can pass through the polymer. Therefore, the degree of translucence or opaqueness of the polymer is directly affected by its crystallinity.
Teflon is often used to coat pans to give them their non-stick qualities. It is a fluoropolymer which is composed of carbon fluoride bonds. The chemical, thermal, and electrical properties were highly desirable in cooking as it was a suitable insulator with a high melting point.
The carbon fluoride bonds are highly unusual because they are not as susceptible to the van der Waals forces. The ability of the atom to be polarized is reduced due to the great difference in electronegativities between carbon and fluorine. This causes Teflon to be hydrophobic, lipophobic, and there is a reduced amount of friction between the pan and its contents. Thus, the pan never becomes wet like other pans not coated with Teflon. Atom transfer radical polymerization is one of the most important processes in chemistry today. It was developed by Professor Krzysztof Matiaszewski in 1995 at Carnegie Mellon University in Pittsburgh. Before the creation of ATRP, it was not possible to create polymers in a controlled way. ATRP allows polymers to be assembled with a highly specific function in mind. It was also cost-effective and has been used to create a number of different coatings and adhesives. ATRP is cost-effective because it can be carried out with normal industrial equipment. Over 40 multinational companies employ ATRP methodologies designed by Matiaszewski and his team. They are currently focusing on minimizing the amount of catalysts used, minimizing the amount of side reactions, and developing more substrates that catalysts can work on. This process can be easily managed. It can be started at will. The catalyst helps achieve the equilibrium between the active and dormant states. The most popular catalyst is copper due to its adaptability in the polymerizations of any monomer. Any polymer can be made with ATRP with a highly specific function which was not possible before. Paints, cosmetics, and pigments are some things that are created with ATRP. The rate of reaction and polymerization is dependent on the ratio of transition metals. For example, how much copper 2+ there is compared to copper 1+. Three components are essential for the reaction: the monomers to create the polymer, the transition metal complex, and the ligand. A ligand is an ion or molecule that can bind to a metal atom to form a coordination complex. The coupled reversible reactions constitute the ATRP equilibrium, which is controlled by temperature and catalysts. Batteries have existed since the late 1700s and have evolved greatly since. They convert their chemical energy to electrical energy, which gives an easily transported energy source. There are two half cells of a battery: an anode where oxidation occurs and the cathode where reduction occurs. And this is a picture of how a battery works. The electrons are transferred by oxidation, and the anode becomes negatively charged while the cathode becomes positively charged. The redox reaction that occurs fuels the batteries as cations are being reduced and anions are being oxidized. Gel polymer electrolytes work in the same way, except the gel polymer is used as the electrolyte. It is a hybrid between liquid and solid electrolytes. Solid electrolytes work less efficiently, and liquid electrolytes can be bulky and rigid. However, gel polymer electrolytes have relatively the same performance as their liquid counterparts, despite the ease of electron flow in liquids, and this is demonstrated in the graph. They are ideal due to their lightweight, durability, improved safety, and increased flexibility. Higher voltage on a weight basis is another characteristic of gel polymer batteries, which makes them ideal for portable electronic devices. Research is currently being done to explore the feasibility of gel polymer batteries in hybrid vehicles.
Osmosis is the movement of solvent molecules through a selectively permeable membrane into a region of higher solute concentration, aiming to equalize the solute concentrations of both sides. Equilibrium is reached once sufficient water has moved to equalize the solute concentration on both sides of the membrane, and at that point net flow of water ceases. This can be applied to the use of diapers. Disposable diapers contain sodium polyacrylate. It was invented by scientists as the result from polymerizing a mixture of sodium acrylate and acrylic acid. This is also the same chemical found in astronaut absorbency garments and toys that grow when water is added. Superabsorbent polymers are partially neutralized polyacrylate with incomplete cross-linking between units. Only 50 to 70% of the COOH acid groups have been converted to their sodium salts. The final chemical has very long carbon chains bonded with sodium atoms in the center of the molecule. When sodium polyacrylate is exposed to water, the higher concentration of water outside the polymer than inside draws the water into the center of the molecule via osmosis. Sodium polyacrylate will continue to absorb water until there is an equal concentration of water inside and outside the polymer. Heat and water cause wrinkles. Heat breaks the bonds holding polymers in place within the fibers of the fabric. We have learned that when exposed to excessively high temperatures, chemical bonds can be broken. When the bonds are broken, the fibers are less rigid so they can shift into new positions. As the fabric cools, new bonds form, locking the fibers into a new shape. This is how ironing gets wrinkles out of clothes, and why letting clothes cool in a heap fresh from the dryer will instill wrinkles. Water is the main cause of wrinkling in cellulose-based fabrics, such as cotton, linen, and rayon. The polymers in these fabrics are linked by hydrogen bonds, which are the same bonds that hold together molecules of water. Absorbent fabrics allow water molecules to penetrate the areas between the polymer chains, permitting the formation of new hydrogen bonds. The new shape becomes locked in as the water evaporates. Steam ironing works well in removing these wrinkles. Le Chatelier's principle states that a system in equilibrium will respond to stress in such a way as to counteract that stress. For example, equilibrium will be stressed by the addition or removal of various reactants or products. Because reactants occur when molecules collide, adding more of one type of molecule will favor its collision with other molecules, thus increasing the probability that it will react. During the chemical process of synthesizing plastic, if there are additional reactants added, more products will be created.